Hello friends, today the discussion for electric current and charge flow starting now. Now what is electric current? In general, electric current is flow of charge. But at first you must realize the name charge. So what do you mean by charge? Charge, actually there are only two charge, electron, negative, proton, positive. These two fundamental charge, they are fundamental charge exist in our universe, mainly electron and proton, and both value of the charge is 1.6 into 10 to the power minus 19 coulomb. So for electron it is minus and for proton it is plus. Also the amount of charge is always taken as E. So it is E, 2E, 3E, 4E, etc. So you can't get 1 into 10 to the power minus 19 coulomb. Not possible. Similarly, 50 into 10 to the power minus 19 coulomb, not possible. So the charge which can divided by 1.6, so charge, net charge divided by 1.6 into 10 to the power minus 19 equal to number of E, that is electron or proton. Everybody knows that electron can move, because in general we can say this is nucleus, there is proton, neutron chargeless quantity, chargeless element, and in surrounding the rotation of electron takes place, so that is negative. In general, suppose one proton and one electron means 1 H1. This is known as protium. The protium is the minimum atom, the smallest or lowest atom. Without atom, proton normally not exist. So when we say one electron is taken from the protium, then the protium becomes like this, only P, but there is no electron. So electron less hydrogen or protium is known as hydrogen ion. H plus means it becomes positively charged. So you have got some idea that when electron and proton both are there, the net charge of 1H1 atom is 0. But when it becomes ion, you got a plus E charge, right? So this is a plus E charge and this is a minus E charge. So this is the charge, separated positive negative charge. So whenever some object, say some material, is a material, it is maybe a human body, maybe a chair, table, desk, metal piece of metal, everything. A body consists of very large number of atoms, and sometimes atoms can be known as molecules. When it is helium, neon, argon, those are inert gases. Those are one atom equal to one helium atom equal to one helium molecule. So this is known as monoatomic. But one oxygen atom plus another one oxygen atom, that is O2, 1O plus 1O, that is one oxygen molecule. So this is known as diatomic, monoatomic. Similarly, you can got 1O plus 1O plus 1O atom, 3 oxygen atom. 3 oxygen atom consist of one ozone molecules. But in case of metals, this is known as triatomic, or sometimes known as polyatomic. So monoatomic, helium, neon, argon, all inert gases are monoatomic. And oxygen, nitrogen, hydrogen, those are diatomic. Similarly, O3 molecule triatomic, S8 molecule polyatomic, like this. Now, when the metals are concerned, suppose it is a copper metal, the copper atoms are connected in such a way that they are form a lattice or crystal structure. Copper. This is a special type of bonding, and these copper atoms having some free electrons. These free electrons for metals can easily move when a potential difference just applied. So the electrons coming inside the metal towards the positive end of the battery, of EMF E, and then we can say, and from here also electron moving negative direction to inside the metal. This is known as electron flow. Electron flow, that is flow of charge, electron flow. But in very old days, the electron, proton, neutron and the charge behavior unknown mostly, and that is why everybody predict that current flowing from positive terminal to negative terminal. So this type of current is known as conventional or normally current. Conventional. That is this way everybody knows that current flowing from positive to negative, but actually electron flows through the metal, and these electrons are loosely bound, but they are always fitted or connected with the atom. Those are known as parent atom. But when the energy is so high, the electrical energy is so high, the current, that is electron, some of the electron, those are loosely bound, start moving. But as the metal consists of thousands of millions of atoms, so they always oppose the flow of electron, and that is why the flow of electron is less, velocity of the flow of the electron is very low compared to current. Current is a instantaneous flow. The conventional current is significant for this, that the current, that is a bulb, can glow within a fraction of second, but the electron flow not so high speed. Now in general, Coulomb's law for electrostatic. What is Coulomb's law? Now suppose you have two charged particles, that means one is say minus or plus, another is also say plus, and these are separated at a distance r. Suppose this is Q1 and this is Q2, and this is vacuum or free space, no material are there, free space. Coulomb law says that the force of attraction or repulsion, when two positive charge there is repulsion, when two negative charge there is repulsion. So positive repulsion, negative also repulsion. So charges are moving from their close contact, close entity to far away. But when there is a positive charge and negative charge, this is known as attraction. But all these cases there is some force of repulsion, force of attraction, etc. So as the force of attraction or repulsion concerned, according to Coulomb's law, this is, so suppose this is charge Q1, this is charge Q2, and the center to center distance between two, say, point charge, center to center distance between 2 point charge, say r. force of attraction or repulsion, positive negative, positive positive, or negative negative. The force of attraction or repulsion F is directly proportional to the product of the charges. Directly proportional to the product of charges. Again, force of attraction or repulsion is inversely proportional to the distance between them. Inversely proportional between the distance square between the distance square, inversely proportional to the between the distance square. So this force of attraction or repulsion, in case of Coulomb's law, it is product of two charge, directly proportional, that is charge more, force more, and also it is inversely proportional to the square of the distance between them. Square of the distance between them, you can like say square of the distance between them, but there is also another entity affect the force between two charge particles, and this entity is known as medium. So if the force of attraction or repulsion depends upon medium where charges placed. Now what is medium? Medium means say air, water, glass, oil, anything. Now if there is no medium, that is free space, that is no medium. If two charge Q1, Q2 placed in a free space region, between distance r, the force is depend upon a special constant which is known as 1 by 4 pi epsilon naught into Q1 Q2 by r square. So force of attraction or repulsion is depend upon these value, where epsilon naught is known as permittivity of free space. So in this condition, permittivity of free space, it is readily available that if there is some air, water or glass etc., medium may be air, water, glass, oil etc., then obviously there is some another permittivity. This permittivity is known as E, permittivity of the medium. Now these two permittivity are known as absolute permittivity. Absolute permittivity of free space, absolute permittivity of the medium, etc. Now what happens if the permittivity is there? If the permittivity is there, the force changed. Though charges are same, distance same, the force of attraction or repulsion changed. This is the speciality of the medium. But the epsilon naught or 1 by 4 pi epsilon naught is a constant. So what is the value of epsilon naught? The value of epsilon naught is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Simply Q1, Q2 are Coulomb. Force is Newton. Obviously, the unit of force is Newton. We can say like this: F unit Newton. Q1, Q2 unit Coulomb. It is known as N. This is so. The force unit is Newton and Q1, Q2 is Coulomb. Now R is meter, unit meter, that is length. So we can say 1 by 4 pi epsilon naught Q1 Q2 by R square is F, which means epsilon naught equal to 1 by 4 pi is a constant, no unit, Q1 Q2 by F R square. Now putting the units, that is Coulomb, Newton, meter square. So it is easily available that epsilon naught is some value Coulomb square per Newton per meter square, or Coulomb square by Newton meter square, whatever you can remember, just like this, and value is 8.854 into 10 to the power minus 12. This is calculated, or this is coming from various experiment of charge. Now if 1 by 4 pi epsilon naught calculated by some instrument, suppose this calculated 4 into pi into epsilon naught, right? 8.854 into 10 to the power minus 12, 10 to the power minus 12, right? Okay. What is the value you got? 1.1126, 1.1126 454 into 10 to the power minus 10. This is actually inverse, that is 1 by. So which is becomes answer to the power minus 1, 8.9877, great value, 8.98742 So if we put the point, we got 1 2 3 4 5 6 7 8 9. So we can say 8.9877. Just throw out this type of number. These are very small number, because point and then at this. So we can say this is approximately equal to 9 into 10 to the power 9. So 1 by 4 pi epsilon naught can be taken as 9 into 10 to the power 9 Newton meter square per Coulomb square. So 1 by 4 pi epsilon naught can be written as, sometime it is written as K, sometime it is written as K. So in problem solving condition, we can use this value directly without using 4 pi epsilon naught. So we have force of attraction repulsion equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, which can be written as K Q1 Q2 by R square, where K equal to 9 into 10 to the power 9 Q1 Newton meter square per Coulomb square. So if you put this Q1 Q2, it is Coulomb square. So Coulomb square to the power minus 2 cancel out, and distance R, meter square and meter square cancel out, so it becomes Newton. So force becomes Newton. So correct, dimensionally correct, unit also correct. Now if there is any medium, so epsilon is permittivity of medium, and epsilon naught is permittivity of free space, right, vacuum or free space. So if we divide epsilon by epsilon naught, if we divide epsilon by epsilon naught, we got a second value which is unitless. This is known as relative permittivity, relative permittivity, or we can say epsilon equal to epsilon naught epsilon r. With this, our formula again changed slightly. What is this? The formula changed. 1 by 4 pi epsilon naught epsilon r. 1 by 4 pi epsilon naught epsilon r into q1 q2 by r square. That is 9 into 10 to the power 9 divided by epsilon r q1 q2 by r square. That is 9 into 10 to the power 9, that is k. So k by epsilon r. As epsilon r is a unitless quantity, you got the result accurately. So final equation becomes, so in any medium force of attraction or repulsion is 1 by 4 pi epsilon q1 q2 by r square, or F equal to 1 by 4 pi epsilon naught epsilon r q1 q2 by r square, or F equal to 9 into 10 to the power 9 by epsilon r q1 q2 by r square. So in case of free space, or it is written as k by epsilon r q1 q2 by r square. For free space epsilon equal to epsilon naught, that is epsilon r equal to epsilon by epsilon naught equal to 1. So that is why F equal to k q1 q2 by r square is the most useful formula if the charges are in free space, and k equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the key idea of force between two charges. Now this force for any unit charge when attracted by unit charge positive, when unit positive charge, when attracted by another charge charge q, say plus q, so it is repelled, say repelled, better, repelled by another charge plus q, that is there is a charge q and there is a plus 1 charge and there is a force of repulsion, right? The distance is r. So according to Coulomb's law, the force equal to k q into 1 by r square. But this force is now only depend upon the distance, because for a fixed charge q you have different force. If this is here, this is suppose r1, this is suppose r2, then it is r1 square. For this p, force at p, suppose this is force at q, or say s, t, s. So when force is s, at s, if s, force at s is k q into 1 by r2 square, So it is obvious that R1 square is more, so attraction is repulsion is less, this repulsion is more because distance is small. So enter the area of the charge, enter the space of the charge, there is so many point, there is so many point. Suppose this is R3, this is T, so Ft is kq by R3 square. So there are so many points, all are actually invisible, because if you eliminate 1 coulomb charge, then there is nothing in the space around the charge plus q. So what is this space? This space is known as field, electric field, and this electric field for plus 1 charge is written as not F but E. Suppose this is EP, this is ES, this is ET. So when 1 coulomb charge placed nearby another charge, then we got electric field, the value of electric field at a point. So the value or magnitude of electric field at a point near a charge q at a plus q, say at a distance, maybe it is minus q, there is repulsion, or there is repulsion, and in that case it is attraction. So the value or magnitude of electric field at a point near a charge plus q at a distance r is known as electric field E at that point. So E equal to 1 by 4 pi epsilon naught q by r square, free space. You can write E equal to 9 into 10 to the power 9 q by r square. The unit is, now one charge is not there, so it is written as force by charge 1 q. So this is known as force by charge, that is Newton by Coulomb. So unit is Newton per Coulomb. So unit is Newton per Coulomb, that is force by charge. So field is Newton per Coulomb, 9 into 10 to the power 9 Newton per Coulomb. Or you can say E equal to kq by r square, Newton per Coulomb. In SI system it is Newton per Coulomb, where k equal to 9 into 10 to the power 9 Newton meter square per Coulomb. So here not Coulomb square but Newton meter square per Coulomb, right? Otherwise the value becomes what? Coulomb square or Coulomb square, right? Because this is Coulomb. So Coulomb cancelled 1 Coulomb and Newton is there, meter square cancelled by meter square. So Newton per coulomb is there, so it is same. Okay, and also the field is E equal to K by epsilon r Q by r square for any medium, Newton per coulomb for any medium of relative permittivity epsilon r, or you can write E equal to 1 by 4 pi epsilon naught epsilon r Q by r square, or you can write E equal to 1 by 4 pi epsilon Q by r square. And absolute permittivity epsilon. This is very important because sometimes it is very much confusing thing, that is, what is epsilon r, what is epsilon naught. So everybody should understand this epsilon, meaning of epsilon naught, meaning of epsilon r. Always remember epsilon equal to epsilon naught epsilon r, always remember. And in free space only epsilon equal to epsilon naught, epsilon r equal to 1, only free space. Otherwise this is the only formula, you always remember. Suppose there is two charge, this is plus 5 coulomb, this is plus 6 coulomb, and this is distance is 2 meter. Find the force of repulsion. F equal to how much? What is F? Very simple. Use direct formula. F equal to 1 by 4 pi. What is the condition of surrounding? Epsilon equal to, or say epsilon r equal to 80, right? Suppose relative permittivity no unit, so it is 80. 1 by 4 pi epsilon naught epsilon r q1 q2 by r square. So F equal to 9 into 10 to the power 9 by 80 into 5 into 6 by 2 square. So what is the value becomes? 9 into 10 to the power 9 into 30 divided by 80 into 4. 0 0 cancel. 80 into 4, that is 27 by 16, that is 27 by 4 into 4 into 2, right, into 100 into 100 into 10. How much zeros gone? 2 to 4 5. How much zeros are there? 9 into 10 to the power 4, right? That is 4 4 25 25 to 5, 25 25 625, 27 into 625 into 5 into 10 to the power 4. This need that much of Newton, but it is very difficult. It is more easy if you divide directly. 27 divided by 32, 27 32. Sometime in exam you don't have calculator, So you must do this by yourself. Approximately 0.84 Newton. If I check it by calculator, how much? This is 9 into 30 divided by 80 divided by 4, 27 by 32, 0.84375. So it is, calculator gives 0.84375. Now what is the value of 10 to the power 9? It is unchanged because there is also 10 to the power 9, 10 to the power 9 Newton, right? 10 to the power 9 Newton, 0.84 into 10 to the power 9 Newton. So force is 0.84 into 10 to the power 9 Newton, right? If you write like this, 9 10 to the power 9 into 5 into 6 divided by 80 divided by 2 square, or 2 divided by 2 times. So you got the result directly. How much? 84375 0000, 84375 0000, 1 2 3 4 5 6 7 8 9, 0.84 into 10 to the power 9. So this is correct. So this is the amount of force between two charges. Now you think that the amount of charge is so enormously large. Why? The charge is enormously large because the Coulomb charge, 1 Coulomb charge is a very large amount of charge. This is not a very small amount of charge. 1 Coulomb charge is very large amount charge. So we know that number of electron or proton into 1.6 into 10 to the power minus 19 equal to total charge. Total charge. We can say N is number of electron, E is 1.6 into 10 to the power minus 19 equal to total charge Q. So that is why we can write Q equal to 1 Coulomb, E equal to 1.6 into 10 to the power minus 19. So N equal to Q by E, that is 1 by 1.6 into 10 to the power minus 19 number of charge, which is 10 to the power 19 by 1.6, that is 10 into 10 to the power 18 by 1.6, that is 100 into 10 to the power 18 by 16. So how much is there? How much number of electron or ions are there? This is 100 divided by 16 becomes 6.25, right? 6.25 into 10 to the power 18 electron or protons or ions, whatever. The number is so large, 10 to the power 6 is million. So million electrons or protons or ions consist in 1 coulomb charge. So 1 coulomb charge generally not available in real field. Most of the charges are micro coulomb, that is 10 to the power minus 6 coulomb, equal to 1 microcoulomb. Sometime more smaller charge are there, 10 to the power minus 9 coulomb, that is 1 nanocoulomb. And also 10 to the power minus 12 coulomb, that is 1 picocoulomb. These are mostly available charge in most real field, microcoulomb or picocoulomb or nanocoulomb. Now another thing is there, if this is a charge Q and if this is a field, that is distance r, there is a point P, and if at infinity there is a plus 1 charge, that is unit positive charge placed here, we know that the field at this point is how much? The field is E equal to k q by r square, right? Now if 1 coulomb is 1 coulomb potential energy, this topic is electric potential energy. Now if there is a charge at infinity, and we bring this charge, bring a unit positive charge from infinity to a point P, from infinity to a point P, at a distance r from a point charge Q, plus Q, say. The work done by the charge is potential energy, at P. Now how can you find the potential energy at P? So potential energy at P, you can consider a small length dx, which is at a distance x from the charge. So obviously electric field here is E equal to k q by x square, right? K q by x square, right? So as it is k q by x square, and you just take this 1 coulomb charge from infinity to this point, suppose this is dx, you just take this charge from infinity to this point, this q into dx, q into 1, suppose this q into 1, so it is becomes force into dx, that is into dx. What happened? Force into displacement, work done to move a very small distance dx, work done to take a positive 1 coulomb charge from infinity to this point, and then you can just move dx distance. The work done dw, small work done, is f dx equal to kq by x square dx. So we can say this is potential energy of this point. So potential energy equal to kq by x square dx, right? This is small potential energy or work done dw. There is some positive negative sign, but these are not important now. We just show the calculation. So this is plus q, this is a p point which is at r, this is a dx distance, and this is a infinity plus 1 coulomb, and this is x, distance is x, and this is dx. So obviously f dx equal to k q by x square dx. So potential energy, small amount of potential energy due to this type of displacement becomes like this. So if you integrate the total journey from infinity to that point P, the total work done is from infinity to P is W. So W equal to integration infinity to P, that is R, distance of P is R. So infinity to R, k q by x square dx. So work done is W equal to infinity to R, k q by x square dx. So you have k q infinity to R 1 by x square dx, which is where k is 1 by 4 pi epsilon or 1 by 4 pi epsilon naught epsilon r, or you can say 9 into 10 to the power 9 by epsilon r. Always remember this part, that equal to kq. Now integration 1 by x square, integration 1 by x square dx is x to the power minus 2, integration dx, which is x to the power minus 2 plus 1 by minus 2 plus 1, that equal to x to the power minus 1 by minus 1, that is minus 1 by x. So this is becomes minus 1 by x infinity to r, minus 1 by x infinity to r, which is kq, minus comes out becomes, we know that for definite integral the limit, upper limit, just put upper limit for the x. So 1 by r minus 1 by infinity, right? Now 1 by infinity means 0. 1 by infinity means 1 by large value is tends to 0, so this is no result. So we have minus k q by r, or 1 by 4 pi epsilon naught epsilon r q by r, right? This is known as work done at point P, So potential energy at P is opposite to work done, because work done is by the force. This is positive charge, and we try to take this charge from infinity to this point. So there is a ripple, that is force repelled it outward, but it comes inside. So that is why the negative sign occurred. The work done opposite to the force, like frictional force, like any other retarding force which can retard the motion. So that is why negative sign comes here. So potential energy, that is energy stored in the particle, energy stored in the charge, is positive at P is equal to minus W. So potential energy equal to k q by r, or 1 by 4 pi epsilon naught epsilon r q by r. This is potential energy, which is sometimes known as voltage in current electricity. This is enough for today. Thank you for watching.